STEM fans, are you ready? Let's hear it for the world-class NASA STEM Stars team. From NASA centers across the country, we present Dr. Nicky Fox.
Hello, STEM fans. I am Dr. Taisha Batts, and I'm coming to you from Langley Research Center. Today we have with us Dr. Nicky Fox, the Director of Heliophysics. So, Dr. Fox, how does it feel to be a STEM star today?
It feels stellar to be a STEM star today.
And Stella is a great word. So we are so excited to have you with us today for our 78th episode, and we're going to go ahead and get started. So, first, tell us a little bit about yourself. Tell us about where you were born and a little bit about your childhood.
Yes, certainly. So I was actually born in England. I was born in a small market town about 40 miles north of London. And there you can see me as a baby with my mum. I liked, obviously, as a little one, I was very curious. You can see there I really liked to read. Fortunately, that picture has the book the right way up. So I'm very happy about that because there's several pictures of me with the book the wrong way up. You can also see there my favorite teddy bear, who was called Heidi, and I actually still have that teddy bear. She's been all over the world with me, and she doesn't look quite as fluffy anymore, unfortunately. I grew up in Hitchin, as I said. I was always really interested in space and in science, particularly in science. From a very early age, I always just liked that. I was fascinated about like how things worked and what caused things to happen, and then I really loved space. I was very inspired by my father from a very early age to just think that space was wonderful. He always wondered what was out there and was fascinated himself by a lot of the NASA programs in particular. So he followed, Apollo. I was actually a few months old when Neil Armstrong landed on the moon, and my dad got me out of my crib because it was during the night and propped me up in front of the TV, and he takes full credit for me therefore being interested in space because he always said to me the best thing you can do in life is work for NASA. And so I was very motivated to study science from an early age, but I also really loved to do theatre. I did a lot of dance from an early age, and I really enjoyed doing tap. And you can see here that's my dance troupe did a little production of I think it was a chorus line that we're doing there. So that was actually performing one singular sensation in my top hat. And I also did ballet and modern jazz, and I played a fairy in Midsummer Night's Dream there. And then my big thing I really loved to do was act. And so when I was at school, up through high school, I acted in a lot of plays, and so you can see me there. I was Cinderella. And then I also got to play the Queen of Hearts, which I definitely preferred playing the baddie. You always got better lines, and so you can see me there as the Queen of Hearts with Alice in Alice in Wonderland. And so I did a lot of activities as well as studying at school. So I was pretty busy growing up.
And I can see that. It's always amazing to me how many STEM people that I know really were STEAM people and did a lot of theater and acting and chorus. I know I sang in chorus. And that wonderful picture that you had of you in the ballet, I could tell that your mother used her ingenious for that because you told me something special about that. What was the bottom made of?
So that was actually made of yellow Kleenex tissues, and my mum carefully attached each one. I think they were stapled and then she had to put sort of ribbon around the inside of the belt, so that the staples wouldn't catch on the leotard there. But yeah, she actually, and the Queen of Hearts costume, she sewed all the hearts on, and you couldn't see from the front there because there's just like one strip of hearts, but the whole of the back was covered in those little red felt hearts. My dad actually cut them all out, and my mum sewed them all on. So they did actually, and the earrings there were Christmas tree decorations. so we sort of all got together and made a lot of the costumes, to do all the theatre work.
Yes, and I definitely remember making costumes or coming up with costumes for different choruses. It's amazing what you can put together when you have to put it together. And so
Yes, it
it's
is.
great. Yeah, it's great to see that, that continues on, because that's what science is that out of the box thinking that you still have to bring in together. So it's amazing to see that. And so, STEM fans, we have a new segment here at NASA STEM Stars that's called Lightning Round. And this is where I'm going to ask Nikki some rapid fire questions, and she's going to give me some one word responses. So, Nikki, are you ready to start?
I'm ready.
All right.
Time for NASA STEM Stars Lightning Round.
So, STEM fans, you know that we're really competitive here. So, we're going to put that leaderboard on the screen. And so, Nikki, we are trying to get at least 10 questions in 30 seconds. I think we can do it.
All right, I'll give it a go.
All right. So, put 30 seconds on that clock for us. And here we go. City or country?
City.
Early bird or night owl?
Early bird.
Talker or texter?
Texter.
Pen or pencil?
Pen.
Comedy or horror?
Comedy.
Pizza or pickles?
Pizza.
Introvert or extrovert?
A bit of both, but I'll go with extrovert.
Shopping, online or in person?
Online.
Scuba dive or skydive?
Skydive.
Homework or yard work?
Homework.
Homework. And Nikki, you got 10 questions. So we are excited. Yay! We are competitive here. So when you were talking about one of the questions you said, I said introvert or extrovert, and you said a little bit of both. So tell me, when is your extrovert side out and when is your introvert side out?
So I always think of myself kind of as a confident introvert, maybe. But I do like a lot of self-reflection, and I know that one of my weaknesses is I'm very very self-critical, and I kind of play things back all the time, and sometimes I think I overthink things. But I can usually push down that sort of insecurity and go with my more extrovert, outward appearance. So most of the time, I'm an extrovert, but I do get into my head quite a lot, and do have some introvert tendencies.
And I completely understand that. I actually do the exact same thing, which is why it's hard for me to watch these National STEM stars afterwards. I'm like, oh, I should have done this. So I definitely understand. So we're going to talk a little bit about college before we go to what you do at NASA.
Mhm.
So I normally try to research and find out everything I can about my NASA STEM stars. And I remember that I saw you in a TED talk, and you
Mhm.
were talking about college. And you said that in one of your classes, you were actually asking the wrong questions. And so I thought that that was really interesting. So explain to me what you meant about that, about asking those wrong questions in that class.
Yes, so it was interesting. So I went to college first of all, and I studied physics as an undergraduate. And by the end of it, I wasn't quite sure if that was really what I wanted to do. And so I went and did a master's in engineering. And I did a telecommunications and satellite engineering. And it was a 1 year master's. And all the time, my professors kept telling me, you really do ask the wrong questions, meaning I was focusing on the wrong aspects. And so they told me, you really think like a scientist, not like an engineer. I was always more interested in why something was happening rather than how it was happening. And so, instead of just plugging something in and taking the results, I was kind of interested in, in why we wanted to take the results, not just, do it and get your answers. And so it actually motivated me to go back into physics. So I did then pass my master's and then went back and did my PhD in space plasma physics, or sort of, space physics, and loved it. And I really enjoyed doing the engineering degree, but I definitely am, I think more like a scientist. But I think having the balance of that, having that engineering experience has definitely made me appreciate our engineering colleagues and the amazing thing that all of our NASA engineers do. And I absolutely love working with them. And that's actually been one of the best things about my career to date, was getting to be the scientist who worked with the engineers. So that's kind of where that comment came from.
Oh, and that is amazing. It's great that, you be able to see both sides of it because you have the engineering and the science, and so you can see both aspects. And I think that that's really important, and it's great that you ask those questions because here you are with us today. And so we're going to kind of see about what you actually do at NASA. So I think we have a picture of you in a clean room. So we're going to start with that.
So this is my favorite place to be. Is in a clean room with whatever mission I'm working on, and the beautiful mission you can see in this picture is Parker Solar Probe. And so before I actually came to my current job, I worked at the Johns Hopkins University Applied Physics Lab up in Laurel, Maryland. And there I got to actually work on a number of missions. The first one I worked on was the Van Allen probes, that were two identical spacecraft that orbited through the Earth's radiation belts and studied kind of how the particles move around in there, how they're guided by magnetic and electric fields, and how stuff that comes from the sun actually changes those radiation belts. They respond to things that come from the sun. After that, I got the pleasure of working on Parker Solar Probe, and you can see another view of the spacecraft there. Actually, you're kind of looking from the top. The whole spacecraft is lying on her side, and so we're actually looking at the top. And that red sort of wagon wheel looking structure is where the heat shield eventually was placed. But the thing I love about this picture is the gentleman that's kind of right in the center looking at the spacecraft. That is Eugene Parker. And this mission is Parker Solar Probe. And so I had the honor of taking Gene into the clean room to actually meet the spacecraft that bore his name. And Gene wrote a paper back in 1958 that really sparked the interest in the sun and how the sun affects us here on Earth. And because of that, we renamed the mission, we named the mission for Gene Parker, and it was the first time that NASA has ever named a mission after somebody while they're still alive. And so Gene actually joined us at the launch site, and I've kept in regular touch with him. We launched in 2018, and I've kept in regular touch with him as we get new science results from Parker Solar Probe. So that was a sort of a big highlight for me. And then I left right after launch, actually about 3 weeks after the mission launched. I came down to NASA headquarters, and here I work as the director of Heliophysics. And heliophysics may be a word that people are not familiar with, and it literally means kind of everything under the sun. It is the physics that is driven by our sun, and helio being a word for the sun. And so we study everything from the very core, the very center of the sun, all the way out to the very edge of our solar system. And it's where the sun's influence kind of wanes away, and that's where we meet interstellar space. We meet all of the vagaries, things that happen outside our solar system. And so the heliophysics division studies everything from the very center of the sun all the way out to the edge of the solar system. Most of the things we deal with is the sun's effect on us here at Earth. But obviously, as we return to the moon and then journey onto Mars, we will study all of that. We call it space weather. So just like you have terrestrial weather here, we have space weather in space.
And that's amazing about all of the things that you study as part of heliophysics. And so we actually have a question from one of our STEM fans. Irene wants to know, what is really a clean room? So why is it called a clean room?
That is a fantastic question. And so a clean room is literally a room that is so clean. We use all kinds of like HEPA filters and airflow and all different ways to actually make sure that there are no contaminants in the air. Because that spacecraft, we want it pristine. We don't want anything on there damaged. And even small dust particles can cause damage to, we've got very, very sensitive electronics inside that spacecraft. And we want to make sure, of course, that it works when it gets on orbit. And we have varying levels of clean rooms. So obviously you can see we are in that clean room and we're not in like full clean room gear. Like I don't have anything over my mouth. You can see that. We don't have any really sensitive optical instruments on Parker Solar Probe, but some of the clean room environments are even higher class than the one that you see there. And you're in sort of a full clean room suit with boots and full gloves and a full head covering, because we have a lot of particles on our skin. So you often have to go through what we call an air shower on the way into the clean room, and you stand in a little room and you literally get blasted with air, and it takes all of the particles and things off you before you go in, because the most important thing is that spacecraft needs to work when it gets on orbit.
Yeah, that's amazing that, it blows everything off of you. It makes me think of like that sci-fi movie when they step in and all of that stuff is taken away, the same kind of
Yeah.
principle. Uh, yeah, we have one of our sim fans asked another question. They want to know, how can you know what's in the center of the sun? I guess they're asking, how do you know that you're actually at the center of the sun when you're studying it?
That's a really good question too. So, and we, there really isn't a surface on the sun. I mean, it's a big ball of light essentially, and a big ball of gas. But you can use a lot of different techniques that can look at different areas on the sun. And you can measure sort of the temperatures, you can measure the densities, you can do some spectroscopy. So that's a sort of a way of like looking at the fingerprint of what the sun is made of. So you can sort of break down and look at all of the different elements that are in there. And each element has its own signature. And you can look at those signatures in different ways. One way is spectroscopy, and it's basically looking at the light that comes. It's a unique light signature that comes from each of those elements. And so we can do that, and we can learn all about the sun itself. We can't go into the center of the sun because the heat is so vast that we would never be able to survive it. Parker Solar Probe is actually going closer to the sun than anything has ever been before. And I mentioned having a heat shield on there. That heat shield helps protect all of the electronics and all of the sensitive spacecraft stuff from the intense heat close to the sun. But we continue to do more and more technology to enable us to get closer and closer to our star.
It's amazing how you can use those instruments in that spectroscopy to see all of the different aspects. And so another STEM fan actually had a question about when you talked about space weather. And so they know what regular weather is, but they want to know how space weather would affect a spacecraft. So how would that cause a problem with the spacecraft?
These are fantastic questions. We've got great STEM stars out there. So a couple of different ways that spacecraft can be affected by the sun. So if you look at the sun, obviously you don't look directly at the sun, but if you look at an image of the sun on the internet, you can often see little dark splotches on the visible surface of the sun. We call those sunspots. And those are very intense sort of pockets of magnetic fields. And if you look at some of our solar spacecraft, if you go look at Solar Dynamics Observatory, or SDO, you can look at those beautiful images on the web, and you'll see that there are big loops that come from these sunspots. And they're literally loops of magnetic fields. So they're very, very strong magnetic fields. And they have solar material that kind of, sort of goes up and down them. It gets constrained by those little loops. Those loops can break and throw literally billions of tons of solar material away from the sun, moving at millions of miles an hour. And sometimes those sunspots are facing us here at Earth. And when that happens, we will get a direct impact of something coming from the sun. And the effect that we feel here, we call space weather. So if you're a spacecraft and you're sitting in the path of that big event coming towards you, there are different things, but sometimes you can get impacted by very high energy particles. They can do damage to sensitive areas of the spacecraft, particularly solar cells or any kind of optical equipment. So sometimes you can see cameras kind of it looks like it's snowing in the camera, and that is the radiation building up on the front of the camera. Usually it goes away after a few days, and we can use the camera again. But solar cells can get damaged, and then they can be permanently damaged, which means that your spacecraft will not have as much power anymore. So we usually put a lot more solar cells on than we need, just because we can protect from that. Also, if you think inside the spacecraft, we've got a lot of very sensitive electronics. If you bring high energy particles into electronics, you can cause a lot of problems. Sometimes we call them single event upsets, because it's an event that causes an upset, and you can't predict it. It's just going to happen. And so there's some of the ways that spacecraft can be damaged, but we put a lot of effort into protecting our spacecraft. We put a lot of shielding on them to try and keep away or keep out that radiation to stop our spacecraft getting too badly damaged.
It's amazing how you think about weather, but you don't think about the spacecraft and the space weather that's out there that may interfere with the spacecraft. So it's a wonderful question, and our STEM fans are brilliant, more brilliant than I was at that age, probably. So I know that at NASA, not only are you working, but you also do some outreach and you do a couple of talks. So talk to us a little bit about the outreach that you do or the talks that you have.
Yes, it's actually probably my favorite part of my job is really getting to share the excitement of what we do at NASA with other people. And I was trying to think of what are my hobbies, what are the things I like doing most when I'm not sort of doing my regular work. And this really is my favorite thing to do. We just do such amazing work at NASA. We push the boundaries of what is possible. We are always going to new destinations. We're using new instruments. We're finding out more things about our place in space. And so that I really love going out and talking to, my favorite is probably middle school girls that I really enjoy talking to, because I remember being a middle school girl and struggling a little bit with exactly what I wanted to do with my life. And I loved going and just telling people what a wonderful career science is. You can do almost any job with a good science background. It really does set you up for almost any career you want to do. And at the same token, NASA is just such a diverse group of people that work at NASA. It's almost, if you think of any career that you might want to do, there's probably a job for you at NASA. It takes thousands and thousands of people to put these types of missions into space. And it isn't just the scientists and the engineers, it's all of the other people that help to make those missions become a reality. So that's what I really love to do is go out and tell people that whatever it is you want to do, there's probably a job for you at NASA.
And that's true. I hope that a lot of STEM fans have seen all of the different jobs and careers that we have shown at NASA. And, we do have wonderful scientists and engineers, but it takes a whole group of people to put together those missions. And so, whatever you think that you might do, you can still have a career at NASA. And that's a wonderful thing to know, especially if you think to yourself, well, I don't know about science, or if I'm ready for science, but there are other aspects. So I had another question. It's actually based on a quote that you gave. I asked, what was your favorite quote? And I'm going to have to read it to make sure that I get all of the words, but I really like this. Keep your face always towards the sunshine, and shadows will fall behind you. So tell us why that's your favorite quote, Nikki.
So it's got a lot of meaning to me. I mean, obviously, I study the sun, and I think of so Parker Solar Probe always has to keep that heat shield facing the sun, and so I always think about that spacecraft is always facing the sun, and the shadow that is behind keeps all of the instruments cool and keeps all the electronics cool, and so that enables the mission to fly. But I think also, in my life, I've always tried to, no matter what happens, and everybody has bad things that happen to them in life, but there's always, if you keep facing towards the positive, you can sort of put the negative stuff in the shadow behind you and just keep moving forward, because there's always a tomorrow, and there's always good things to come in your life. And so that's kind of why that quote means a lot to me, personally, as well as it really fits what I do in my job too.
And that is amazing about the quotes, and everything that you said is, because when I read it, I thought sun, solar, I got that together. But it's great that you put all of those things together in a quote. And we have time for one question. And this question is from Miguel. And he wants to know, how long does it take to get the feedback from like the solar probe to where you actually get to see that feedback? How long does that process take?
So it depends on the orbit. Actually, so that's a really good and a very detailed question. So the spacecraft herself, she does sort of petal shaped orbits. So goes very close to the sun on one side of the orbit, and then comes out actually around the where Venus orbits, comes out that far away from the sun, and does that 24 times. And so it kind of depends where the Earth is in respect to the spacecraft, how quickly we get our data back. Sometimes we're in the perfect location with the Earth, and as the spacecraft is coming out of the solar encounter, we can download the data straight away. And there are other times where we have to wait almost 2 full orbits, so it can be nearly 6 months until we see the data. And it really just depends on where the Earth is, and if that heat shield is blocking the antenna, because the most important thing is that the heat shield protects the spacecraft. And so sometimes we just have to wait patiently, and it's hard to be patient when you've got this great data coming. But typically on average, it's about 3 months before we see the data, but sometimes I get a sneak preview in just a few days.
And that actually leads us to a wonderful challenge that we have for the students, an exciting one. So today, STEM fans, we want you to actually put together how different aspects of the solar system are surrounded by the sun. And so what you're going to do is called Solar Pizza, and you're going to actually use a representation of the sun and show us the measurements of those different objects in the solar system. So we expect for you to, and we hope that you actually send us your results at hashtag NextGenSTEM. And don't forget to tune in for our next NASA STEM Stars, where we have Roberto Navarro, who's going to be here next Wednesday at 2 o'clock. So before we leave, STEM fans, we're going to let Nikki say the last words of advice that she has to our STEM fans that are out there.
So I would say to you, you know, be whatever you want to be. But close your eyes, think about what it is you want to do with your life, and remember to dream big. Because if you can't be it if you can't dream it. And so close your eyes, dream really, really big, and follow whatever it is your heart tells you you want to do. And hopefully you'll come and work at NASA.
And we're going to be excited to see you there. So thank you, STEM fans, for another wonderful episode, and have a great rest of your day.